In question 5a, we are asked to prove that if OAP were to form a triangle and OBP were to form a triangle, that they would be congruent. For this question, we need to use the SSS congruency test. Okay, the first side we're going to find is that BP is equal to AP because they're both radii in the same circle. OP is a common side, and BO is equal to AO because they are also radii in the same circle. Therefore, triangle BOP is congruent to triangle AOP. For question 5b, we need to prove that triangle OAM is congruent to triangle OMB. Now for this, we're going to be using the SAS congruency test. So the first side that we're going to find is BO is equal to AO because they're corresponding sides in congruent triangles. OM is a common side, and the angle is that angle BOM is equal to angle AOM because they are corresponding angles in a congruent triangle. Therefore, triangle BOM is congruent to triangle AOM. In question C, we need to prove that AB is perpendicular to OP, and we also need to prove that AM is equal to MB. Now, we know that a line through the center of a circle that bisects a chord is perpendicular to that chord. Therefore, AB must be perpendicular to OP because it satisfies this criteria. Now we know that angle BOM is equal to angle AOM because they are corresponding angles in congruent triangles. This makes M the midpoint of AB. Therefore, AM and MB must be equal because they share a midpoint. In question D, we are asked to state under what circumstances will OAPD form a rhombus. Now, OAPD would form a rhombus if two triangles are formed, one from points OAP and one from points OBP. Now, if you can imagine two triangles formed, you'll see that it creates a four-sided shape, therefore making OAPB a rhombus. Now in question D, we are asked to prove that arcs AL and MB have equal lengths. Now we know that angle AOL is equal to angle BOM because they are vertically opposite. We also know that equal angles at the center of a circle subtend equal arcs. This means that because angle AOL is equal to angle BOM, that therefore arc ALL must be equal to arc MB. In question E, we are asked to prove that AFBG is a parallelogram. Therefore, AFBG is a parallelogram because their diagonals bisect each other. Now the final question in question 5, F, we are asked to prove that ABCD is a rectangle. Now the final question in question 5, F, we are asked to prove that ABCD is a rectangle. Now, a quadrilateral is considered a rectangle if the diagonals are equal and they bisect each other. Okay, so OA, OB, OC, and OD are all equal because they are radii. Another way to say this would be to say that OA, OB, OC, and OD all equal R. Therefore, AC equals OA plus OC. Or you could say AC equals 2R because OA and OC both equal R. So R plus R would be 2R. BD is equal to OB plus OD. Or another way of saying this is BD equals 2R because OB and OD both equal R, and R plus R is 2R. Okay. Therefore, AC equals BD equals 2R. These diagonals also both share a common midpoint in O. So therefore, AC and BD bisect each other. So therefore, ABCD is a rectangle.